My name's Jeff Hannam and welcome to this StarSound tutorial. When you open StarSound for the very first time, you'll be greeted with this window. And the first thing we should do is just check that we've got audio playing through the software. To do that, we'll go to File under the main menu and then go to Preferences. Under the Preferences window there are two tabs. Choose the second one, which says Audio. Under here you can select your audio drivers. If you're on a Mac, then your driver should be called Audio. The input device can be left as is, and the output device will be either through your speakers or through your headphones. Once that's selected, you can close the window. Once you've done that, there is also a visual cue which is presented on the interface itself. In the bottom right hand corner, you'll see this blue speaker icon. If it's blue, then the audio is on. If it's grayed out, then the audio is off. To hear any of the sonification, make sure that the speaker is blue such that you will now hear sounds. And under your audio driver, it should be set to call audio. Before working with any data, the first thing we'll do is set up a project folder. This is where StarSound will save all of its files during your work. So to do that, go to the main menu and under File, select New. On your desktop, select New Folder, and I'm just going to call this Test and simply say Create and then Open. StarSound is now looking at this particular folder. To begin with, we'll use the template data that comes shipped with StarSound. So under the main menu, Template, select Load Template All.
Loading template.
Once that's complete, you'll notice that on the right-hand side of the visualizer, there is a config template which sets and initializes the application for certain types of sonification, and underneath that is a data template which contains all of the data. You'll notice as well that StarSound reports when certain actions happen. You can turn this voice off by simply deselecting here or coming under Play and deselecting voice from within the Play menu. Now that we've loaded our template, we can actually incorporate it within the application. The first thing we'll do is we'll load the template file and select the config template. Once that's selected, it's going to take a couple of seconds to initialize the system, and you'll see some changes occurring across the visualizer, across the software. From there we can now select our data template. Okay, so before proceeding, what I'm going to do now is simply save my project. And what this will do will save all of the data, configuration and the data file into that folder that we created earlier. I'm going to take a look at the data file. So what you see here is a headerless text file which contains 8 individual columns, and each of these columns is represented visually within the application. You'll also notice that there is a configuration folder, and in that is the configuration file, which is also a text document which you can edit yourself, and you'll see that at the very first line we have the headers for each one of our columns. And that will become important when we start to think about how the system sonifies data. To load your own configuration file or data file, you have a number of options. You can simply come across to this right-hand panel here and simply click Open Config, and so I can select that configuration file even though it has not been edited. it will still allow me to load that configuration into the system. And that also is the same for any data file. Once that has been loaded into the system, you'll notice that you now have multiple configs available, which means that you can switch between different configurations, but also different data files as well. So once we have our configuration and our data file loaded into the system, we can change the look and feel of the data just to make it a little bit more pleasant on the eyes. Underneath the view section here, you can change this to rainbow and envelope, and that will just color code each one of these data columns. Depending on your data, you can also make different transformations to it. Currently, there is no transformation being applied to it, and so it is set to pass. But if you wish, you can apply a whole variety of different mathematical transformations to view your data in different ways. I'm just going to put this back to pass. Just be aware that any transformation performed on the data will also change how the data is sonified. For now, we will leave trace alone. To hear your data as sound, you simply have to hit the spacebar. Hitting spacebar again during its playback will immediately stop it. Another form of interaction that is quite useful is to scrub through the data, and this uses your mouse to do that. To activate the mouse as a scrubbing feature, simply go to the main menu and under Settings, select Mouse Scrubbing. Here the mouse is mapped to the extent of the visual graph. To turn that off, simply come up to Settings again and select Mouse Scrubbing, which will deselect it. Underneath the visual display, we have a number of mixing options. Each column within our data file is represented by a different color within the graph, and each of those columns is assigned its own sonification module. So mod 1 is sonifying the very first column of data, which is the red one across the top. Mod 2 is assigned the second column, which is colored pink, and so on. If we wish to mute any of these columns from the sonification, we simply hit the M button within each of the modules. You may also notice when playing back some of your data that it's shifting from left to right across a stereophonic field. Currently, each data column is assigned a panning feature, and that is represented by this large P and this slider, which is the visual indicator of where it is within the panning. To prevent your data from panning across the display as the cursor moves, you can simply deselect this and shift these either to the location that you wish to hear. With the P on, it will automatically pan depending on where the cursor is. And to finish off this section, on the very right hand side you have the master. The master also has a loudness fader as well as a mute. Clicking the mute on the master will mute all of the channels, all of the available channels within the system. We'll now move on to the mapping process and how you can begin to map your data to sound. And we do that by going to the very top, and to the right of the Visualization tab there is a Modules tab. So when you select this for the very first time, you'll be greeted with a blank window. However, if you come across to the right hand side of this window, there is a drop down menu. If you select that, you'll see that there are up to 12 independent sonification modules in which you can select. Currently, using the configuration file that we have, it's only initialized 8 of those modules. So selecting up to 8 will allow you to see each of the settings for each of the independent modules. Let's go to module 1. So for module 1, we can see on the left hand side there is a drop down which will allow us to switch between different types of audio signals. The first of which is set to, is tone. Below that is instrument, and that will play a MIDI musical instrument for the sonification. To the right of that, we also have a mute button, which is currently deselected. Then we have a pulse, and the pulse is a very short sound with an attack and a decay in which you can set within the mapping window. By turning the pulse off, we'll get cont, which is continuous, and we can hear what that sounds like if we go back to the playback. So I will first mute all of the channels and then unselect mod 1 and then hit play. Switching it to pulse will now turn on the duration, so it's ramping up its attack and its decay, so ramping down. So let's play that. One thing you might notice on playing that one back is that we have a long duration for low frequencies and then a short duration for the higher frequencies. And this can be changed within this mapping window here. To the right of the pulse button, we have different voices that you can apply to the tone selection. Currently we've got voice 1. Be aware, however, that these voices are experimental. I recommend that you choose either voice 1 or voice 2 for your sonification tasks. However, you can hear these and the different sounds that they make by selecting them as it's playing. Let's have a look at the mapping window, this section in here. And this is where most of the work is done for the sonification. To begin, there are a number of buttons that you'll see on the left hand side, and I recommend for now that you keep these on. To the right of these buttons are some drop down menus. Now remember that our data file has 8 columns, and currently within module 1 the data that is sitting in column 1 is being mapped to frequency, amplitude and duration. Let's first take a look at the frequency. This green button here is being used to automatically map the lowest and the highest range within that first column to a frequency range of 200 that goes from 220 Hz to 550 Hz. If this green button is off, StarSound will not automatically map that data to that range. What that means is I can now insert any value as the high or low range. By switching this back on, StarSound will automatically select the highest value within that data column and the lowest, and then scale it depending on the frequencies that you place in here. For amplitude, the first column within our data is also mapped to loudness. Changing the values in here can vary the loudness of the sound depending on its high and low values. Currently, with values of 0.8 and 0.8 as the low and high, then it will always be maintained at that volume. The highest volume I recommend that you go up to is set to a value of 1, and the lowest is 0. To now play this back, then we should barely perceive the values that are within the low range, whilst as the frequency rises, they should start to get louder and louder. Depending on what you want to hear, it's sometimes advisable to keep amplitude constant if you want to focus purely on the pitch. Sometimes you might also want to change its duration. So for data values that are on the low range, they'll have a long duration, whereas as it gets higher, they'll have a short duration. The value that is applied here, the unit for this value, is in milliseconds. Now let's explore what this might be like using musical instruments. If we come back up to the drop-down menu at the top, we can turn this from tone into instrumentation. And now on the right-hand side, we can choose a variety of instruments that will be played through the system. So with our instrument now selected, we can click on any of these and then play back. One thing to be aware of with MIDI is its resolution. Some data might be lost as it's moving up the scale. And one final word about the mapping. If we come across to the different columns that are present within our data, it is possible to also cross-map different columns within each sonification module. This might be a useful process if there is a strong relationship between the data, and so you might want to explore how one aspect of the data informs another. So that ends this tutorial on StarSound, and if you wish to incorporate your own data, then I highly recommend that you first load in the template, which will also load in the configuration file, and this will give you up to 8 sonification elements within the system. If your data file has less than that, as this data file here, then that configuration file should be suitable. Good luck and have fun sonifying your data.